going to solve for x. First of all, we notice that the base of 3 and the base of 2 are not the same, so we can't change everything to the same base. So we're going to have to use our logarithms, and we're going to have to take the log of both sides. So if I take the log of this side, and sometimes on the final exam, you get up to 1 mark for just doing that step. Sometimes people want to do a whole bunch of steps at once. Like you might feel like I didn't need to, I could have put the 2x plus 1 out in front to begin with because I know that step, and that's fine. However, if you make a mistake by doing too many steps at once, you could lose a lot of marks. So it's not bad to show more work. The most common thing that people get tempted to do here is to bring out the x plus 3 right away. But we can't because this x plus 3 is only to the base of 2. It's not also to the base of 4. You can't multiply this 4 times 2 and get 8 because of our order of operations. We have to do the exponent first. So what we have to do is think of this as 4 times 2x plus 3, and we have a log law, and maybe this time I will take the extra step and do that all in one step. You have to expand it first with adding, and then the x plus 3 can come out in front. Now when you bring those exponents out in front, if there are more than one term in the exponent, you make sure that you put them in brackets. Now log of 3 is a number, so you can distribute it. And you'll get 2x log 3 plus log 3 equals log 4 plus x log 2 plus 3 log 2. So we can distribute the log 2 as well. Now we want to solve for x, so we're going to move all the logs with x's to one side of our equation by subtracting x log 2 on both sides. And we're going to have all of our terms without x's by subtracting log 3 on both sides. Sorry, some of my 2's are starting to look really nasty. I'm working on them. Now that we've got our x's on one side, to get x by itself, we see that there's an x in common here, so we can factor. And we still have log 4 plus 3 log 2 minus log 3 on this side. And finally, we can divide both sides to get x by itself. And now's the big test to see whether or not we have this value right. So I'm going to go to my calculator. I'm going to get it in fraction form. And I'm going to write log 4 plus 3 log 2. Whoops, I forgot to close my brackets. Start again. Log 4 bracket plus 3 log 2 bracket minus log 3 all over 2 log 3 minus log 2. Enter. So apparently 1.57 appears to be the answer. Okay. What we have to do, though, to make us feel more confident that this is right, I'm going to store this value as x. No, I'm going to hit the mode button. I'm going to store that value as x. And now I'm going to plug it back into my original equation. My original equation had 3 to the power 2x plus 1 on the left-hand side. And that is equal to 95.26. And on the other side, I had 4 times 2 to the power x plus 3. And this is the scary part, because if these numbers aren't the same, then we have to go back and look through all of our logs to see where we made a little mistake. It's also the exciting part when you didn't make a mistake. So to store something as x, you hit the store button. It'll automatically take whatever your previous answer was and put a little arrow sign here, and then just put it as x. So now I stored 95.26 as x. It's just stored until you store something else over top of it. And it doesn't affect any graphing things that you do. So when you're graphing with x, it has no effect on it. So in fact, all the letters on here are stored as a certain thing. Usually, if you haven't ever stored something as that letter, so I don't think I've ever stored anything as R, so it comes up as 0. So everything defaults as 0. What you can do is you can store numbers with the letters of your name, so that when you type in your name, it comes out as a 10, but you type in somebody else's name, they come out as a 0. I don't know. Calculator tricks. And it is just a coincidence that our answer was very close to, did anybody notice that our answer was very close to pi over 2? No? Okay. No, it's just neat that it was close. All right, so that is that example. Now for today, we are going to get a handout on modeling exponentials. So I'll start from here, take one, and pass it on.